Yes. Yeah. So I will give you some examples of specific tools that you may be familiar with. So we go more into that kind of stuff now. So the objective is here to find some typical software that you are interested in yourself and learn how to load these, and also have a chat about Python and R packages specifically, and how these work on the systems. So in the previous section, we looked at tool chains, and they often used to install or build your own software, as we heard, but they are also needed sometimes for the different tools you're working with. And you also learn that on some systems you need to load like GCC as a prerequisite, but other times at other clusters these are loaded automatically when you ask for the software. So we will start with some popular tools or other things. Yeah, like other ordinary software, I would say. And then the packages. And in the end, we will dig deeper into your favorite tools in the exercise. Yes. So some of the software out there are available on all clusters, but some software are only available on some because they are a bit niched. So for instance, if you are a bioinfo user and work with sensitive data, you may find your software only on Bianca or maybe Pelle, and so on and so forth. And you have learned that the principle is that you can use module spider or module available, depending on which system you are using. And yes, you know this procedure, and you know also that the capitalization, I mean, lowercase, uppercase, that could be different on the different systems. So you're aware of this. So the first step is to learn the module, which adds the path for the system to find the version you want. Because then we come to the step where you have to start the software itself. So first load the module and then start the software. And the tool name could be the same as the module, but it could also be different. And then it's good to look at the original documentation, either, original one or a specific documentation for the cluster. But you should know that only the most used tools will be documented by us. If you don't find any documentation at the cluster, you have to go to the original documentation of the software. So for instance, if you load OpenFOAM, you should start it with the command foam only. So this is specific for this tool, and it could be different on other ones. But typically use lowercase, but not always. So yeah, you have to find out this. You have to find out this yourself, basically. If the name of the module includes CUDA, that means it will run on the GPU nodes. And then the relevant CUDA version will typically be loaded automatically. So you don't have to think about this. Yes. And you may try one of several tools in exercise 3 further down. And there you will also find some more information about MATLAB and OpenFOAM. but you can also do as you want. You can look after your favorite tools and see if you find it, and maybe how to start it as well. So if you have time, you can continue with that as well. Some notes about licenses. Yes, as you know, some programs or software is license restricted. That means that you may not be able to load this software, or you may load it, but then you can't run the software itself. So then you have to make sure that you are part of the licensed, the user group that has access to the license. So one way is that you have your own software that you want to install, and it's licensed. I mean, not your own, but you install it yourself. You have to provide the license as well. It can also be larger software where we provide the license, and then you have to ask the support if you can be part of this license group, basically. Yes, so here are some more information. Other things that one can think about is that some software are using graphical user interface, like MATLAB, RStudio, and some others. That means that you have to log in the right way to get access to these graphics. So the first choice would be to use the desktop environment through ThinLink or a web page, and this Open on Demand or GFX launcher. And you have some information if you go to yesterday's workshop. If you want to use a terminal, you can add X forwarding by adding this -X after SSH when you log in. And this can work in many cases, but is typically slower compared to if you were using ThinLink. Another tip, yes, Camille or Bassam?
Yeah, thank you. I'm not sure I get it with this X option. Does it like
-X.
open directly a graphical things from the console? Or
Yes.
for Air, for example?
Yeah, so I won't show this now, but for instance, you can start an SSH session in the terminal, and when you use this X, graphics will work. But when you come to the session, you are still in the terminal. But then on the command line, you can start, for instance, MATLAB, and then it will open up a graphics window outside the terminal.
Okay.
But this also means that you may have to install some extra programs on your computer.
Yeah, okay.
Yeah. But there should be documentation about these at the different centers.
Okay, thank you.
Yes, and if you're using graphical tool, maybe you want to still use the command line. And by adding this ampersand, for instance, after you have started MATLAB, yes, MATLAB will of course start in a new window, but this, instead of freezing the terminal, which will happen otherwise, using this ampersand, you can still work in the terminal with other things while having MATLAB running on the side, basically. So that's a tip. And this will work for any graphical tool. I should say that when you are working in a desktop environment, you may see in the upper menu different software available, and some of them you could start from there. But if you find, for instance, RStudio or so, or MATLAB, which is not starting on a compute node, you may hear more about this in the afternoon, maybe. Well, what I mean here is that it's typically better to start a software in the terminal, even if you find it in the menu, because then you can choose the version you want. You get access to more packages. This is especially the case if you're using R or Star Studio and R packages on some of the systems. Yes. But if you have questions after the exercise, we may have a couple of minutes to talk about these things. So I think we continue to packages now. So we know how to load a module or Python for a specific version, but then it varies between the classes how many packages are installed within this Python package, with this Python module. But typically we have some base Python packages here, like math library. But if you want like NumPy or Matplotlib or such, it's not certain that it will be included here. So the packages may be installed as separate modules. And this is an overview how it works of the different clusters. So for instance, on NSE, that is Tetralit, there are some bundles like SciPy bundle, Matplotlib. So they are separate modules, basically. And on Arrhenius, it will actually be quite similar, and also quite similar to UPPMAX and LUNARC and HPC to N. And also Chalmers, that's Alvis. What is a bit different is Bianca, because very many packages are here installed within the Python module. And that's how it is. And also, it's harder to install packages there because it has no direct internet. So we have provided many packages inside here. Yeah, so the bundle names, these reflect the content. So, for instance, they can have the name like a Matplotlib, but there are also other bundles that are more, anonymous, I would say, and these can contain many different packages. What you will see for these bundles is that you have the keywords GCC core or these ones, and a version or year. So here we have an example, SciPy bundle, which actually in this case consists of the SciPy package and also pandas and also NumPy. And we will see here that this will go together with the with this toolchain. So we heard about the FOSS earlier. So for instance, if it's 2024A, we will get Python version 3.12, GCC 13.3, and bundle versions 2024-06 and similar. Okay, all right, 5.06 maybe. So here we see something like this. I know that on Arrhenius, we so far have one toolchain that is 2025B, where we have somewhat newer Python version, and also GCC. And you may know this FOSS is for the full level toolchain. This means that we have some math libraries, and GOMPy means that we have also the MPI library, OpenMPI, for instance. So when you're working with bundles in this sense, you have to make sure that they are compatible with each other there. But also typically when you're loading a bundle, some other modules with Python packages may also be loaded as dependencies. And if you load a bundle, it will always get the Python version that is connected to it. So if you want some packages, it's good to start by loading the bundle, because then you will get the Python on the fly. And here's just a list of some different bundles. And if you want to learn more, we have a specific page about different bundles and versions that are available. But this may be different on different systems, of course. So when you work with Python, if you have to think about a number of things. Will you start a new project? Then I will start with the newest toolchain. If you want to reproduce, you go for the version that you have used before. If it seems to be complex environment that you need, it's better to go into an isolated environment instead, and then instead work with Conda or Miniforge and so on. Yes, we have some principles here also. If you want matplotlib, for instance, you can check the versions by this command. You can also do this for the SciPy bundle, and then you will also find which packages are inside this one. You can also search for a different package name. Python package name. It could be xarray. Then, or if you search for NumPy, for instance, this SciPy bundle will show up because this bundle actually includes NumPy. So this spider command is very good in finding where specific Python packages are found. Otherwise, then you load prerequisites if it's needed, and you load it, and you can start Python and import what you need, or run a script where this matplotlib, for instance, is needed. But as I mentioned, sometimes isolated environments are better to use, and then I would point you to a course we have. And if you are using Bianca, as I told you, very many packages are installed already. And here are some tips. And if you're missing a package, this is how to do, or just contact the support. You may know about the IDEs. So for Python, we have these. Jupyter, Spider, also Visual Studio Code can be used. And you will have some information also in the end of this session about these. Before break, I can just say that if you're using R, yes, you don't have to read this right now. You can go back to this. But principles here is to check versions, load prerequisites, start R. And we have the different approaches for the different classes where we either we have bundles, or on Bianca we have a specific R package module with 20,000 packages actually. And yeah, so it's a little bit different on different clusters. And you can read more about this in our course module. And for R, there are bundles on some systems, and they all start with R bundle. So when you do spider this, you will find either the cron one or the bioconductor. Yes, otherwise it works as usual if you're using R. And if you miss package, you can contact us or install yourself. In RStudio, you can have more information from our course as well. So I think we take a break here, and we convene at 11:25. And we have a couple of minutes to just try this exercise out, I guess. So what you will be doing is that you work silently alone, but you choose one, possibly two, which track you want to go for. So either Python, R, or another tool, basically. Okay, so see you again, 11:25, and then we start without any recording, and then we can have a wrap up as well of the exercise.